new one, all of this shit is known. Where did you learn this, man?
I would have thought you would have figured it out in engineering school like I did about 50 years ago.
I'm talking about the mirrored water layer over a flat plane, big.
Well, I'm not talking about mirrored.
No
well,
now
you're asking me what horizon we're pointing at.
Right.
That's not pointing at a horizon. It's pointing slightly above it.
Right. The astronomical horizon is what he pointed out earlier.
Astronomical tangent plane, Pete.
You have to take into account the mirrored water layer he mentioned.
Horizontal reference frame.
Yes.
Which is the astronomical horizon, which is above the apparent horizon, which you see that blue line pointing into the eyepiece is pointing out to the astronomical horizon, and what you see is the blue to the lighter blue. That is the apparent horizon.
Yeah, let me ask you a question, Navigator. Let me ask you a question, please. So when I bring up images of the sunrise and sunset, and I see this mirrored reflection of the partial sun, is this the mirrored water layer it's reflecting in, and I'm perceiving it?
Yes.
Fucking yes. Yeah. The partial sun. I told you, I knew all this shit. Mirrored water layer. I'd like to know how you know that as well. Fucking yes. Yeah. 3 years, man. I told you, I knew all this shit.
Hey, Pete, you know the dodo can't fly, right?
Fucking yes. 3 years, man. 3 years. I told you, I knew all this shit. Hey,
Pete, you know the dodo.
What's up, man? Come on.
So I'm just now getting into the room. What is this guy's argument about?
Oh, there you go. Schrodinger and Navigator.
I'll quickly give you a synopsis. Basically, what he's saying is you can measure the distance to where you would be underneath the sun based on its angle of elevation minus 90. So, take the angle of elevation away from 90. So, zenith.
What?
Yeah, which doesn't work all the time because obviously the sun that would only work based on a solstice path, not on an equinoctial path.
That's not
this whole argument because it quite often doesn't even get to 90 degrees. So you're making a false assumption based on your original calculation. If he wanted to do this calculation correctly, he would need to take the angle of the sun as its zenith on the day he's taking the measurement.
Yeah, because you have to have, if you're going to solve a triangle, you have to know at least one leg and one angle.
Yeah.
Right.
So if you're looking at the sun, you only have an angle, so you can't solve that triangle.
And what he's using the Aristophanes calculation for the circumference of the Earth. That's why he's using 1 degree.
Not the circumference of the Earth.
Miles.
Aristophanes determined the circuit of the sun. If you notice, if you measure the sun at any day of the year, you get 15 degrees every day.
And
that's the Earth's rotation.
No. And you have used this.
I still want to go back.
Eratosthenes only works if you know the distance from your position to the position that is directly under the sun. That's the only time that will work. And only then at solar noon.
And where have you used this in practical application?
Don't work at any time.
Where have you used this in
navigation based on the Earth being stationary and flat. That's
where
how
have
you say 90 degrees is straight above you, 0 degrees on the horizon.
Where have you used this in practical application?
Excellent, Navigator. You made my fucking day, honestly.
He'll make my day if he answers my question. Where have you used this in practical application?
So you just come in, Cliff. Have a little bit of respect, bud.
What, using my sextant to plot a line of position from where I live?
And what were your results?
I was within 3 miles.
Of
not
what?
4 miles.
What
3 miles of what?
Travel? Yeah, how far did you go?
Pardon?
How far did you go?
What do you mean, how far did I go?
How far did you go? What distance did you travel to make sure that your calculations weren't going to actually give a compound error? Because if it's 3 miles at 0, if it's 3 miles at 0, if it's 3 miles at 0, you're 3 miles out each time. If that's an exponential error that you're inferring into your calculation, then at 100 miles you could be 30 miles out.
Correct.
Your metric pounds there is dysfunctional.
I wouldn't use a 100-mile line of position plot.
Okay,
3 miles you were off.
If you're sailing, you would be.
Is that the type of navigation that
if I was sailing and I came up with a 3-mile error, as you call it, then that's no biggie. When you talking about 3 miles, if I'm on the coast,
serious?
I can see
that's the difference between being on land and in a channel.
Yeah, or in a channel or on a reef.
Right. Where have you
or he could
navigated
float
before?
off the edge of the earth. I mean, crap.
Yeah.
So
So
miles, he might run right off the edge of the earth.
Wait a minute. Oh, very important though.
Question, and I need to leave in about 5 minutes. So
what kind of navigator is he?
So what I wanted to ask is, what about the measurement to Polaris, the latitude rays of north, and how that plots on a flat plane? Have you done that?
Done what?
Have you taken the angle of elevation to Polaris multiple times? So you're proving that every 69 land miles that you're moving forward, it's raising 1 degree. Yeah. Have you plotted what shape that needs to be to give you that consistency and angle over those latitudes?
Yeah. Perspective.
Oh, shit.
So no, you haven't was the answer, and you just claim its perspective.
Again.
Okay.
What is the height of the building when you're underneath the building?
If I've got 1 degree separation.
No, you got 0 degrees. What is the height?
I'll take a step backwards.
You don't know. You have to move away before you can get a height, right? So if I move 100 miles away from the building, where is the building's top at? It's on the horizon. So if I'm directly under Polaris and I move away, it's going to drop down.
Oh, hey, navigator. So you talk about 1 degree per 69 miles. We know the Earth is flat. So is it fair to say the spherical coordinate system would apply more to the barrier or the contour of the dome than the Earth?
Yes. And
excellent.
Actually,
what the fuck is going on?
Pete, it's actually both. It's
Hey,
actually
real quick
same
question.
measurement for the dome is the same on the land.
Excellent.
When the sun is at the horizon,
excellent, man.
when the sun is on the horizon,
guys, take care.
5,400
Really?
nautical miles away.
Hey, quick question. You're talking about if you were 100 miles away from the building, you say the top of the building will go to the horizon, right?
Yeah.
Now, will the top of the building lower exponentially or linear? Would that be linear or
What does it
exponential?
do when you walk away from it? You can do this on your own. Stand next to a building and walk away. It kind of comes down pretty evenly, uniformly the whole way.
And Carlos, even on the globe Earth, it's linear because you have that equal distance per 1 degree, right? So it has to be linear, and it should be exponential.
Well,
I'm talking about as far as the building,
but it didn't.
celestial bodies.
I'm sorry if this has already been asked and answered, but on what basis are you calling yourself a navigator? Where have you navigated?
He's not a Team 2 member like you, Cliff.
I was asking the question to him, not you.
I've navigated all around Puget Sound, Hood Canal, Straits of Juan de Fuca, all the way up in between Vancouver Island up to Prince George's Strait.
And so, when you navigated,
when you take a sextant angle and you plot your line position, how close are you?
I use a sextant to determine my latitude, not how close I am to something.
I can use a sextant to determine my latitude too, and it would be the same as using a protractor.
So, make shit of him, navigator. Make shit of this guy.
How do you get a distance with your protractor by measuring an angle to Polaris, for example, or with your sextant?
Cliff,
take your angle to Polaris, subtract it from 90, times it by 60, and that is your distance to Polaris on the geographical position in nautical miles.
Okay, right. Now if Polaris was twice as far away, the angle would still be the same as long as it was linearly twice as far away. How would you get a different result?
Where?
Yeah, this
what do you mean?
You're letting Team 2 down, Cliff.
Okay, I'll ask the question.
Polaris is what it is. We just have to figure out what it is.
Can you stop talking so I can ask the question?
Off you go.
If Polaris is 100 feet away from you and it's 10 degrees above the horizon, now if it's 10 degrees above the horizon but it's 1,000 feet away from you, that angle is still not going to change. So how can you consistently use this whatever formula, it's subtracting 90 nonsense? How does that work?
Okay,
if you don't know how far how far away Polaris is, Have you heard of equivalent triangles before?
Would you say 100? I'm 100 feet away from the building, and the building's what, 100 feet?
I asked you about Polaris.
Polaris, 45-degree angle. How far away is it?
You can't know. Just
To the
by knowing the angle.
of Polaris is 2,700 miles. If you go onto Google Earth and point a point at 45 degrees north and go to the North Pole, it will come out to 2,700 nautical miles.
Excellent.
Okay, now do it at a different point on Earth.
If Polaris is on the horizon, meaning it's 1 degree, it's what? 5,340 nautical miles away from the geographical position of the North Star.
Excellent.
That is fucking stupid.
And of course, hang on, please. And
This guy's just talking bollocks, Pete.
Yeah,
hang on,
that's
please.
not
Let me just read it.
Why do you think Pete's getting so excited?
Because the dodo's been justified, Dean.
Oh my God! By finding one other tad. No, I'm afraid not, Pete.
I asked us which came first, the degree or the mile measurement.
No one cares.
Nobody gives
a
shit.
I'd be looking towards the navigator.
No one cares.
You're all knockers here. The dodos have to be validated and
a sailor right out of boot camp to tell you that you're not.
Oh, just let Pete celebrate his little bit of victory that he thinks he has.
I said this 3 years ago, Maxwell. Right?
You were wrong
3 years ago. I was on my own talking about the mirrored water layer. Now, Navigator here tells me that this is a well-known thing.
He's not a navigator.
Why is there an astronomical?
He's not a navigator. That's not a well-known thing. Full of shit. This guy's just a joke.
If you observe Polaris at 1 degree in your sextant, it is 6,141 statute miles away from your geographical position.
Right. Right. And the point is here that
and how do you arrive at that?
Celestial navigation. 1 degree equals 69 miles. Statute
69 miles. Land miles, not miles to the star that you're observing.
Show me here. How high's Polaris at 45 degrees?
45 degrees.
440 light years.
A trillion miles away. How far is what angle is Polaris?
Say that again.
If you move Polaris another trillion miles away, what's the angle to Polaris?
The same.
Right.
That's what I just told you.
If you measure the sun at an angle of 23 degrees and you move the sun a million miles more away, what's the angle to the sun?
The same. That's what I'm trying to tell you.
93 degrees. Right. So what the fuck are you saying about moving?
Then how are you saying that you can tell how far away that celestial body is by knowing the angle to it?
Schrodinger, he doesn't understand the difference in triangles. That's all.
He's talking this is where the 69 miles per degree comes into things.
I learned about equivalent triangles in 7th grade.
Do you know a flat plane doesn't have degrees on it?
Eric, every celestial body in the sky has a geographical position on the Earth. Right. Your angle to that determines that.
Excellent.
That is, oh my God. I think we found somebody dumber than Pete.
No, it's equal.
This is the reason why. This is the reason why the figures we're giving apply, right? Because everything is known. They know the dimensions of the Earth, and more importantly, they know the contour of the sky.
No, they don't know what the Earth is. They just know what the sun is doing.
Who is they?
The sun has a circuit of 21,600 nautical miles, or 24,901 miles.
I wouldn't let this guy navigate a rowboat.
But hang on. Navigator, they know, let's say, the distance from North America, Alaska to South America. And they also know the equator, which is the highest point along the barrier in this outer area.
Are you stammering,
know these
Pete?
Distances.
You must be stammering. Is that right, Pete?
Right. I was a small bit. I'm excited.
Are you stuttering there, Pete? What's the problem?
Schrodinger. Do you know American Practical Navigator by Nathan Bowden?
Yes, I know the publication you talk about. It says fuck all about what you just said.
Do you have a copy of it?
No, I don't.
No. That's a yes, then.
Wait. Do you know that's the epitome of navigation?
Say it again.
Do you know it's the epitome of navigation?
No.
Ooh.
It's an epitome of navigation.
Look it up,
No.
Schrodinger's cat. You're good at that. Google it. Ex SEAL Team 2 member.
Did you mean when you said
He couldn't find his way to the local shop.
Do you mean epitome?
Yeah, that's what I was about to ask. Do you mean
John.
epitome?
Pardon?
When you said epitome, did you mean epitome?
Yes.
Epitome.
Oh,
That's how it's
Jesus
spelled,
Christ.
not how it's pronounced.
I guess
Yeah.
he likes facades too, doesn't he?
Epitome.
EPITOME, epitome of navigation.
That means
Epitome.
that's epitome. Why are you asking me a
Epitome,
word that you
I have
don't
a
even know how to
knife.
pronounce?
But
These guys can't even
I have-
pronounce the damn words.
I have a knife in my kitchen.
So I can't pronounce words. So
Start
doesn't mean
trolling
I
now.
can't
We're not going to keep it serious anymore. We're just going to start trolling his pronunciations.
epitome of
Really?
navigation.
Oh,
Hey, Piche, you'd like this one. Nathan Bowditch, Piche, bow,
Yeah.
the bow of the arc of the sky, ditch, the ditch of the earth where the water lies. Nathan Bowditch.
Excellent, man. It's all in the names, isn't it? Right?
Yeah, publication number 9. Publication number 9.
Excellent. Do you know about the dodo?
God.
You know anything about the dodo?
Yes, I know the dodo from you.
Not the dodo bird. It's the layout of the land, right? So when we get the Gleason's map and we rotate it.
Hey,
Excellent.
Okay, what was
I
your
done it for
question?
a few
What was
years
your
and
question
brought it up.
about?
Excellent, bud.
Mike,
Excellent.
check.
Let's
You
talk
asked
again.
me the question for a reason, apparently. What was the point of your question about the epitome of navigation?
Oh, that's everybody who is a celestial navigator or navigator of ships, maybe airplanes too, because all that information is derived from that for the Air Navigation Almanac. Is from
The Air Navigation Almanac?
navigator.
What the fuck is
Every
that?
celestial navigator
Right.
will be using those formulas in that book.
The Air
From
Navigation
1835, you
Almanac.
mean? We have now updated navigation since 1835 is what you're asking me?
Can
And
I
if you're such a
US
great
Navy is
navigator,
introducing celestial navigation with sextants because they're afraid of their electronics breaking down.
I understand
Could you
that.
please tell me your
but
formula again? I just wanted to check it
Are
out.
we still on this guy with his, doesn't know how to measure
I'm
up or
about to
down?
be done with him, but I just
Okay.
wanted to ask before.
All
You're
right.
asking me about a book that
Listen to all
came
the
out in
team members.
1835
Team 6.
by a guy named William Noir, and he does not use the formula that you just said, and you don't even know how to pronounce the name of the book. So why am I supposed to believe that you are at all acquainted with that book? I'm done.
Can I have the formula?
Epitome is good. Epitome or epitome. It's the same thing, man. You say potato, I say potato.
Oh, man. So we're just going to
That's
start
the American
trolling.
Tactical Navigator by Nathan Bowditch.
Formula, please.
2017. 1 degree equals 60 nautical miles.
I know you keep
navigator,
saying this.
That's what it is.
You said before I
navigator.
went
We'll
to
notice.
tea.
We'll notice that Nathan also, because you mentioned the surname. Nathan is also almost palindromic, right? Because we have NA on both sides. We have the TH in the center. The T. So very significant. Excellent.
I've been saying that 1 degree equals 60 nautical miles on these hangouts for years now, and you're telling me as if you're bringing me something new.
Could you please give me the formula again, Mr. Navigator?
He's talking to you, the fake navigator.
Oh, pardon. What was that?
It called you Schrodinger's cat. SEAL Team 2 member. It's called you a fake navigator. Dysfunction.
Could I please have the formula again?
Formula for what?
The way that you're navigating.
Ken, are you drunk? Are you in the pool again? You have to get
I'm
the
going
sunburn.
to my position with where I'm at right now. I take the angle of the sun and I plot that line of position on a chart. What's so easy? What's so hard? What don't you understand?
Okay. Angle of sun. Okay, keep going.
Take your angle of sun, 45 degrees, angle to the sun. Subtract it from 90 is 45 degrees. 45 times 60 is 2,700 nautical miles to the geographical position of the sun on Earth.
Okay, if you're at let's say 45 and you want to measure to 35.
Why do you want to measure from 45 to 35?
Because you're at 45.
Oh, this dude is so clueless.
You mean from 45, from latitude 35 to the sun?
No, from 45 to 35. I want to know the distance between those 2 points.
10 degrees, 600 nautical miles.
Yeah, 10 times 60, for fuck's sake.
Yeah.
All right.
Well,
But it
what I
all goes
keep
back to
misunderstanding-
where. Hang on. It all goes back to where did he get the 60 miles per degree from?
Can I carry
that's
on?
what they're asking you.
Can I ask again? What is the significance of that? That is the distance to the sun, or that's the distance to some projected point of the sun on the Earth?
It's the distance to the ground directly beneath where the sun is at. And that's why I say this also tells us something about the barrier against when the sun is...
Which therefore tells us that the sun is incredibly close to the Earth. Is that what you're trying to prove? Is that the...
Yes, of course it is.
I think that's what he's doing, but he doesn't understand
Actually,
triangles.
You guys call yourself smart. You have all the information to figure out what the height of the sun is. You got 1 degree equals 60 nautical miles. You got 20,600 nautical miles of the circumference of the
there's a mistake here.
the circuit of the sun. Now figure out tell me what is the height of the sun.
You're confusing a bunch of different math with other stuff that doesn't make any sense.
Yeah.
You're using nautical miles. You should be using imperial miles. And triangles don't curve like they do on Earth with your nautical crap. So get the hell off your freaking little thing.
So
he's either really confused or lying.
Get the calculator out and follow along. 60 times 360 degrees equals what?
Hold on. What latitude are you doing this at?
This is general.
No,
I think he's just here to troll everyone.
It does not work at the equator. At the equator, it's 69 miles.
Which equals 60
in
nautical
America,
miles.
it would be like, well, actually,
Still
it depends
60
where you are.
nautical
What is your
miles
latitude?
Still 69 nautical miles. Still 69.
You said 69. You said 60 before. If you use 60, you're getting the right answer, and 69 works at the equator. Why is that?
You guys are using statute miles. I'm using nautical miles at 60. 60 is way easier to use.
Cliff says that as well, just for ease of use.
Telling me stuff that I already know.
Right. So basically, Navigator, what you're saying is, at this 45 degrees, you can work out the point on Earth, the distance to the point on Earth that the sun is directly above. And due to the nature of the angle as well that you're measuring from the sun, you can also work out the hypotenuse and the perpendicular height of the sun.
Correct.
That's completely ridiculous. That's the biggest load of rubbish I've ever.
Well, that's what he's saying, but I don't think it's quite that simple myself.
But guess what? Guess what? In this day and age, we can radio range both the sun and the moon.
Sure.
There we go.
Again, 60 nautical miles per degree times 360 degrees. What do you get? 21,600.
Exactly.
Now what do we do? Well, what do we do? We divide that by pi, right?
Right.
What? Why? Just for fun?
Okay, then what do we get? We get 6,875.
Just throwing crazy
miles. Then what do we do? We divide by
60 minutes in an hour.
We divide by 2, and then we get what? 37 nautical miles to the sun.
Toda, I take it back. He is worse than Pete.
How did you determine the 69 miles or 60 miles in your case? That seems like spherical math.
Excellent.
That's what you have to understand.
I've seen no illustration. I've seen no diagram.
On a flat plane.
You get to 60 nautical miles per 1 degree from Eratosthenes.
Yes, but only on a sphere.
Who thought he was at the center of the earth.
No, he didn't.
Yes, he assumed he was at the center of the earth.
I'm gonna have my pudding. I think
3,437 the radius of the earth.
Right.
You flip everything upside down, right, Pete?
That's it, man. That's it. Well, he didn't exist in the first place. An anagram of seas, not Earth, is Eratosthenes, right? He's said to be the first to see Earth in its true form.
Put the AE map upside down and you get the dodo.
Excellent, bud. That's fucking
Flip
excellent.
it upside down.
Pete, and the dodo,
Pete, you have paid this guy.
The dodo came about because, hang on, let me just say this, because it's important, Navigator. See, it all goes back to what we think the sun is as well. So, but yeah, the dodo came about, the changing face of the land, because of the decapitation of one thing, the tree of life, Aristarchus, which we can see in its reflected form everywhere,
Yeah, I got it.
particularly from the
Oh, Pete,
crater
shut up.
/ creator on the moon. Excellent.
Yes.
What pish.
Dysfunctional navigator. I don't know who you are. This is my first time hearing you. I find a lot of what you're saying interesting. One thing I do find disturbing is how a lot of people seem to have been really trolled and angered by whatever you're saying. It's got them losing their minds. So I hope to hear more from you and more from the guys who don't believe in what you're saying.
It's not
Excellent.
just so
And
that
who
you know,
said
just
that
so
there?
that you
Who's
know,
that
witness. It's not that we're losing our minds. It's that what he's saying when we break it down makes no logical sense and would not work. But we're trying to understand where is going wrong. But there are just so many places it's hard to have a coherent thought. So it's not losing our minds. There is no threat. There is no nothing. It's, oh my God, we can't even communicate with this guy. It's that wrong.
Witness, nice to talk to you as well. And you'll notice all of these people act in unison, right? They're a big team. They act together. Whereas all the flat earthers act alone. I'm not in cahoots
I
with
think
anybody.
he might be a troll.
I didn't need anyone else to back me up.
I think I think he's paid by Pete. I think he's
You're
paid by
calling
Pete.
me a clown. Look at the avatar. The avatar is what I'm explaining, Dean. That is out of the American Practical Navigator. That's how you navigate.
Okay, so
why do
navigator,
no
just
navigators
out of
know
question.
this? Why are you the
just
only navigator that knows this?
Just a question. So say you were trying to plot a course over from Vancouver to Japan. How would you measure the distance from where you using your formula? How would you measure the distance to Japan?
Take the difference in longitude, times it by 60. You guys do know plain sailing, right? Plain sailing, mid-latitude sailing.
But you said using your formula that you can measure the distance to the sun. That's what I'm trying to figure out. So if you can use that to measure the distance to the sun, how can you use that to measure the distance to Japan?
Difference in longitude.
Yeah.
Difference in latitude. Plain sailing.
But the degree of longitude varies by distance varies in distance from the poles to the equator.
Right. How do you
Only
differentiate?
latitude are 60
How do you differentiate something that is 100 miles from you at 15 degrees above the horizon and 10,000 miles from you, 15 degrees above the horizon? How do you determine if it's 1,000 or 10,000 miles away from you?
That's horizontally.
What?
You said if I was 1,000 miles
unresponsive to my question.
At 15 degrees and then moved another 100 miles away, it's still at an angle at 15 degrees. You're moving away horizontally.
No, you're moving away at you're moving away at the vector of the degrees. The point is,
you can't have the same degrees at a different distance.
Your answer is quite wrong if you're trying to do this.
It's not even coherent. I can't even make heads or tails of what he's saying.
Yeah, exactly. That's what I'm trying to figure out. Is you're telling us that you can measure the distance leading to a place. I'm asking you to give me, plug it into your formula. How far is Japan in your formula? And you're saying that you're using just plain sailing. At that point, you're saying that, well, the distance doesn't really matter according to my formula.
I think you did a great job today, Navigator, and maybe come back the next time and have a sort of a more open discussion. All these people are closed-minded. And,
well, we're not, Pete, but we'd love to see some pictures or some
right.
evidence or a formula
or
some
maps.
maps.
Area. Listen, let me tell you where the 60 miles comes from. Because
exactly what I'm talking about.
Right.
So I've got a question here, and I'm going to share my screen for Navigator in a second so that I can visually ask
I'm
this
off. I
question.
can't stand this. The Navigator, nice to meet you, and hopefully we'll talk again. And same with you, Witness. Take it easy.
You're welcome,
I wouldn't bother hanging around listening to Dean if I was you, man.
Yeah, because I'm the crazy one.
That's right, Dean. With your pictures, your damn pictures.
Yeah, for God's sake, do not only listen to the crazy one. Right, so I'm going to share my screen. I'm just going to get something up. And I'm going to give you an example of your absolute rule. So let me present.
The other one would be difference of latitude, you moron.
Say again. What? Right, so... just give it 2 seconds.
And my first tip would be dysfunctional navigator. Yeah, calling people names is, not very nice. And as you might have noticed, I'm always really super polite to people because I think it actually helps in a discussion. Because I think the minute you call people names, you've probably lost the argument. Yeah. So I don't think Dean is a moron. We may not be understanding you correctly, and that may be frustrating for you. I understand that because I don't understand you, and it's frustrating for me trying to understand you. But please, just take a leaf out of my book. Be civil to everyone.
Oh, give me 2 seconds.
Yeah, but you got to take the same stand against your team. Like when Brenda starts that stuff, I never hear anybody step up to shut her down.
I do try, but it's very difficult, Slick, sometimes. And as this guy is new,
didn't Brenda get booted from a call yesterday?
Yeah, that's true. And also it usually ends up with two people talking over each other and everything like that.
And it's really difficult to even get a word in then, yeah. But, my general tip would be being respectful is nice for all of us, right? And I think it makes a better, happier place for everyone, yeah. I don't mind people, getting a little bit rambunctious, but all this moron, you're an idiot, you're a retard, and, it's not good stuff.
Moron.
Right, I am almost ready.
Hey, Tony, maybe you can have a conversation with Rumpus when you get a chance.
I will.
How to figure out
I did the
the
other
height
day,
of
and
the
I
sun?
will.
1 degree equals 60 nautical miles.
Doesn't work.
You guys couldn't figure it out? How smart are you? 1 degree equals 60 nautical miles.
It doesn't.
Times 360 degrees. Gives you 21,600.
That's what we're not questioning. We're not questioning your math in that instance. We're questioning what your distance. You say you can measure the distances someplace. That's what we're questioning.
Correct.
Subsolar or subcelestial.
What's margin of error?
Yes,
What's the margin of error?
It's going to be a two-part thing for on the Earth. You have to use difference of longitude and difference of latitude to find the distance.
So what's the margin of error?
Margin of error.
What are you basing the latitude and longitude
No, I am.
off
I'm just sorting something.
Yeah, minuscule there.
So how do you find the margin of error?
What margin of error? What are you talking about?
What do you mean? You said you plotted a course and you were 3 miles off. So where's the margin of
I didn't
error?
plot a course. And if you know anything about celestial navigation, you'll never plot a line of position exactly at your position.
Right, so my question is quite simply this. If I have this, so we've got a very special triangle of 45 degrees, 45
I just want to say thank you, StingRay, for doing this because this will pretty much shut it down.
So here's the issue. So actually, let me draw this a little bit smaller for you. So at 45 degrees, give me again the distance that you say something is going to be. At 45 degrees from the level. Yeah? Are you ready? Are you still there? Yeah, so this is 45 degrees. Yep.
Right.
And I'm looking up now, and this is the way that I'm looking.
Yep.
From the level plane?
Yeah, awesome.
What do you want to use up there? Sun or Polaris?
Doesn't matter according to you. So here we go.
Yeah, why would it matter?
So what is the distance here, which is what your formula relates to?
2,700 nautical miles.
2,700 nautical miles. So if we've got 45 and 2,700, do you know how to work out this?
Yep.
So what is h then? Distance. Since we have a 90 here, it should be quite easy.
Yeah. So we can use SOHCAHTOA, can't we?
So do you know how to work this out as a navigator?
Working it on it.
Okay.
Do you know what trigonometry is?
Let's just.
I can already tell you what he's going to do without even knowing. He's going to give you an assumed distance at 90 degrees.
Right. But how did he
We
even
don't need you
arrive
to
at
work it out. We
27
just would like to hear how
degrees?
you think we should work it
Right.
out.
Yeah.
But how did he even arrive at 2700?
Yeah, we don't need the answer from you.
So here's okay. I've got another question. So let's assume that you are correct here in the let's assume that let's just go with this 2700 miles. Yeah, whatever units. I don't care. How have you determined that this is not all the way over here?
Because the North Star is above the North Pole.
Hang on, is this a sun or a star we're taking a bearing on? I thought this was the sun that we were bearing on.
You told me not to, it didn't matter, so I'm using it as Polaris, and Polaris is right above the North Pole.
Okay, so I think it does matter.
Yes.
I think it really does matter a lot because you see, if this 2700 miles was correct and the 45 degrees was correct, then I could work out the distance, from the surface of the sun. Right? I could use trigonometry and I could work that distance out, right?
Yeah,
that's going to be different.
Yep.
Okay, and that's going to be very different for the sun, as the moon, as the stars. They're all going to be very different.
Yep.
So therefore, the 2700 miles cannot be correct because it must vary, right? So if this is the moon, it's closer than if it's the sun, it's much further away. And if it's a star, it's even further away.
If I measure the moon at 45-degree angle, its geographical position on the Earth is 2,700 nautical miles from me. If I measure the sun at 45-degree angles, the geographical position of the sun on Earth is 2,700 nautical miles away.
Which would mean that the sun and the moon are at the same height at 45 degrees.
Yeah.
Right.
And the stars.
And the stars. Ah, right.
Oh, so do you think all celestial bodies are the same distance from us?
So the dome, right? Okay.
That's what this math suggests.
Okay, so we can work out the height of the dome now.
You're a practical navigator.
Got it.
He thinks that all celestial bodies are the same distance away.
Of course. Got it. It's all a dome. They're all projected on it.
Of course.
We live on a stationary platter.
Jeez, that took forever. That took forever to get through. Why couldn't...
Now, do you know the really interesting thing about this is we can actually prove that is wrong. Yeah?
But why couldn't you have just told us that up front?
Freaking fill in the rest of the fucking blanks.
Gotta go.
Why did you let out of you instead of just telling us?
We've been here 2 hours and I had my tea in the middle. You could have...
I just told you. The angle to the sun and the moon and the stars are as if you're on a stationary flat Earth and they are rotating.
Yeah, you didn't actually mention that earlier, did you?
Per hour, every day.
I said he was trolling us. Okay.
Right. Okay. And do you know all the arguments against that?
You guys have a wonderful day.
We can prove it as well.
Navigation by
He's running.
Trolling. That was just ridiculous.
That was a troll, wasn't it? It was a 2-hour troll.
Yeah,
he was
Why does the math work? Why does the math work?
He was throwing these numbers out.
Because it's
throwing his ideas out.
Put a point at 35 degrees. Go to the North Pole. Count me 2,700 nautical miles. Come on, prove me wrong.
very much a troll.
Right. Goodbye. Have a nice day.
Bye.
That was terrible.
That was a waste of life, wasn't it? I'm glad I had my tea and didn't forgo it to listen to that. He did it deliberately, though. He was obfuscating there, wasn't he? Because he was telling us it was this 60 nautical miles and how to calculate it. Yeah.
Well, he did admit up front to being dysfunctional, so...
Robot Maxwell.
Yeah, we can't hear you, Maxwell.
What the hell he's saying from the get-go. I said he came in here knowing that people aren't going to understand what the hell he's talking about and thinking that he's got something right when he doesn't tell the whole story about the position of the stars and blah, you know, I mean.
And he started the whole sextant thing against Druss, right, and said to Druss, you got it wrong, you're not adjusting to the middle of the earth, which was rubbish anyway, because why the hell would you adjust to the middle of the earth? But yeah. Oh, how annoying is that?
At least we can work with numbers and real things.
Yeah, and I'm calling bullshit that he has ever navigated anything successfully.
No, he's never
Wait a minute. I love
don't
the
doubt his
way.
navigation skills at all.
No, I love the way everybody's saying, what's the difference in 2 miles? Well, it's it's an inlet or it's land and water. It's the difference between international waters and declaration of war as well in some circumstances.
Yeah.
Right. And it's definitely, I mean, hundreds of yards are the difference between being in the middle of a channel and being grounded.
Yeah.
But what was his idea of navigation? He said that you could get the angle and then work out where something was on the real world.
He's saying that the subsolar point is going to be 60 nautical miles per degree of elevation to the subsolar point or the sub-celestial point for stars.
Well, that's why I pointed out where's your margin of error, because he's not giving the full factor of the system.
Right.
But
well,
he's just confusing the factoid that 60 nautical miles is 1 degree of latitude.
But
and
if nothing else,
he's somehow transferring that to the sextant and the inclination of the sun and the stars and the moon, saying the same thing.
Well, yeah. On the bright side, we did learn new epitome. I didn't know that was a word.
Epitome?
Well, epitome.
Yeah.
Epitome. Oh, right,
epitome.
Yes. Yes, it's the
He
epitome of
cited the book
stupidity.
and didn't know how to pronounce the title of the book.
Well, at least it's not an epitaph.
That's not a big deal, though. I've mispronounced words before. So.
He's done. He did that on purpose. He did that on purpose.
That is one word that I would mispronounce when I saw it written. There are a few. Paradigm is another one that really.
Oh yeah, paradigm's a hard one, isn't it? Yeah, paradigm.
A schema.
Can I?
A schema. Never mind.
Oh well, it gives us nothing to talk about now.
Wait a minute, Barney's here. Barney, where have you been? Oh, and why have you changed your name?
Yeah,
no, this is my name.
Sorry?
This is my proper name.
Why are you called this Vedran Aberletovic or something?
Vedran Aberletovic. That is my proper name.
Oh, is it?
Right.
Yes.
Barney for short.
I had the Barney nickname since elementary school, something like that, and I've always used it online as my kind of online alias.
So can we still call you Barney?
You can still call me Barney. That's
all right. It makes it easier because I think Vedran is a little bit more tricky.
Yeah, that's kind of the main reason why I use it. Wrong Barney. There was a British cartoon, something like Barney the dog with stars in his eyes, and
let's play.
There was a British cartoon, Barney the dog with stars in his eyes, that had a mouse on his head. It was a bobtail, and I was the only one in my town who had a bobtail while that cartoon was running. So people started calling him Barney, and then there's Barney, there's Barney, there's Barney, and it kind of got transferred to me. And everybody calls me Barney. My mom calls me Barney.
Brilliant. We'll call you Barney.
Nice.
I've got a quick question for Sean, if Sean's here. Did you have a conversation with Sleeping Warrior? Because I think he posted something maybe yesterday where gravity came up. And I think, what's he called? Al K did a really good piece around this whole gravity thing. But it was a bit ridiculous. Was that a while ago or was that recently? Do you know the thing I'm talking about, Sean? Can anyone hear me?
Yes.
Is Sean still here?
Sean Smith is muted.
Yeah,
Sean
I'm sorry.
G.
I'm in the office right now.
Oh right, is that Sean G? Right, okay.
Oh no, Sean G's left, I think.
Oh, has he?
He's still in the panel.
No, Sean G's here but muted.
All right, I just wondered. Yeah, no, I just seen something online that Warrior.
We need to get Sean Hawkins in here to get more Seans.
We do. We need 3 Seans. Another very quick question: is Sleeping Warrior, now avoiding what's he called? Nathan's show? Because I haven't seen him on Nathan's show recently. Does anyone know? Yeah, he's not been on it for a couple of weeks. I just wondered if he's avoiding it now that Ranty has got his own little thing. No answers, no one knows. And how about Ranty's show? Anyone seen the latest one about the guy who doesn't think that nuclear bombs exist?
Oh dear.
Yeah.
Oh my goodness.
Yeah.
It seems that there's an error in that guy's math.
Yeah, that goes back to Eric Dubay. Eric Dubay started that.
Oh, did he?
Yeah.
I did from the English Channel to Georgia, which is about 42 degrees difference. There's an 800-mile error using his method.
Nice.
Yeah.
Well, that's because he didn't give you the full method.
None of the angles things work on a flat plane.
I mean, you have to know the position of the stars. It's just he was given half of the factors.
Well, also the fact that the Earth tapers, so at different latitudes and longitudes, it's not 60 miles per degree.
No, but you can be pretty accurate with the sextant if you use all the factors, and he wasn't given all the
not
factors.
60 miles. At 69, or sorry, at 54 degrees where I measured, it's like 40 miles, or 40 or 50, 40 to 50 miles per degree.
Oh, at Earth's surface, the distance per degree of latitude and longitude of curvature of the Earth is 60 nautical miles, or 69 miles, or 111 kilometers per degree. That's a fact. That's correct. If you want to calculate the distance off a map, you can read out the longitude and get out the distance. That's fine. It just doesn't apply to every angle everywhere in the universe.
No, well, actually, it's. I mean, I don't know if you're saying the same thing, but it is substantially less. At the North Pole, let's put it that way. Go 10 feet from the North Pole. Every degree is 10 feet.
Of longitude.
No. Every degree of curvature. Every degree of curvature, right?
Yeah.
No, you're talking about longitude. Latitude is 60 nautical miles per degree. Longitudinal lines converge at the poles.
Right.
Yeah.
So yeah, it is true worldwide, but only for latitude.
Yeah, but Barney's just saying it doesn't forget latitude and longitude. It's just any direction from a tangent 1 degree on the surface area is 60 nautical miles.
Yes.
But Barney, while you're here, because I can leave this running, and I am streaming this as well, but I can leave this running if anybody wants to carry on talking. But I've added 2 things to my flat Earth model, and I to explain flat Earth a little bit. And I just want I want to show you, and then I want any input that you might have, but the input cannot be negative. It's got to be towards the positive outcome of flat Earth actually working.
Okay.
But I thought you might be good at this, and anybody else in the panel as well.
I'm looking forward to this. I haven't seen a model yet.
So first of all, I have got this sun to illuminate, not perfectly, but illuminate with the distance parts of the globe that you would expect, given a little bit of error. Yeah. Now I've done that by creating a cubic energy fall off for this sun, because if I leave it at inverse square law, it obviously illuminates too much. So
far too far. So you've not got a shade around it or anything. You've done
no, because we don't see. Yeah, we don't see the shade. Yeah, okay. I try. So I've got, I could do quadratic, cubic fall off, anything.
Okay. Cool.
So cubic fall off gives me kind of this. So I can have one side, illuminated, and one side in kind of darkness. I'm going to say that the atmosphere, and I can't do that at the moment. The density of the atmosphere is going to account for, not lazy light, but the light actually, not making it all the way to the surface. Now, the other concept that I came up with is I need to get this sun to set. So, this might be a little bit weird, but I came up with a theory of fraction, or fractive light. Yeah? So what fractive light is, and you know how we can, do you know we can have inverse index of refraction materials that are synthetically made?
Inverse?
Yes.
How do they work? They pop things up? No. Down? No.
They
How do they work?
they inverse
Yeah.
Snell's law to the opposing side of the denser material. It's predominantly used to research for invisibility, camouflage and stuff like that.
Oh, really?
But it's never naturally occurring. But what I thought was there could be a naturally occurring phenomenon for it, which can bend light in the correct way quite severely based on some energy signature of that light that we can still not detect. That, I don't know, let's bury it at the quantum level, which I've yet to model this in to show it visually, so I can set so that I can set the sun. But I'm open to any positive ideas of how I can get this damn model.
Well, when would that?
Do you know that this has been modeled?
What which bit, Barney? All of it.
He's modeled it.
All of it.
And it works.
Walter Business, yes.
Oh
you
yeah,
seem
no,
to have
yeah.
an exceptional amount of twilight on your planet.
Yeah, that includes that's for a personal dome though, Barney.
Oh yes, of course.
Yeah, I don't want that because that's ridiculous.
So
as opposed to the other things.
So on yours, Dean, this material that you've got, could that not also be moving around as well, so that the two coincide at a certain point, so that you start to get the sun? Because you need the sunset and sunrise, I presume, to occur, don't you?
Yeah. Sorry, what were you saying, Charlie?
So at the moment, just if you could explain, your light is going around, yeah, and you're not getting a sunrise or sunset. What if it actually? So how are you going to make sure that you've got the sun in, I don't know, South America when it's dark, or I don't know, in the UK or something? Because you're still going to have that one sun, aren't you? So I was thinking, like, you could go into a cloud of something that is this material that you've spoken about that could start to make it set, but I don't quite understand how that could be moving around.
What if the sun moved around in like a figure-8 pattern or something, or an elliptical pattern?
No,
that still doesn't get it closer to the ground. So the way that the fractive effect
No, I mean,
works.
okay, more like a Mobius pattern.
What if this material is only at a distance, a certain height? Yeah, if your fractal material is like.
Sorry. No, so I was referring to the synthetic made material. My fractive light theory is just about the light energy. So it's not about a material that exists between, and it's some quantum effect that causes the same thing that we try and make, which inverses Snell's law, but it's based on something about the energy that we haven't discovered yet, which, given a certain distance, and let's say an exponent distance away from the sun, makes it bend light upwards severely, thus pulling it down.
And this could not be a cloud of this fractive material moving in the opposite direction or something, so that it coincides, so you get the sunset wherever it is. Do you see what I mean? So visually in the UK, you get the sunset at the point that you need to have the sunset and sunrise. It cannot be like a counter-rotating, like wave or cloud cover of this material. You can't.
Would that work?
I don't know. I'm just, I'm spitballing, right? I'm just trying to work out because you're still going to have the sun illuminating somewhere else, aren't you? While you're also seeing the sun setting in another place, aren't you?
Yeah, that's the main problem. Yeah.
That is the main problem, that you're going to have the sun looking two different ways from two different locations, right?
Dean, do you have proper ray tracing in that? Can you emulate refraction?
Yes.
Yeah. Have you seen those people putting semispheres or crystal semispheres and then pointing a light from outside to show the illumination as it properly is? Even illuminating, having the shadow of the right shape and the light of the right shape on a flat Earth.
No. Have you got a link for that? I'll have a look.
I need to look it up. I don't have it on hand, but I distinctly remember somebody showing it to me.
And is it a consistent refractive index in that volume?
Yes.
Then? Oh well,
yes.
yeah. I could easily emulate that. Piece of piss.
I will look it up and I will send it over somehow.
Yeah, just post it in the side chat. That'd be cool.
I don't think. Well, I'll try, but in that case, I'll be silent for a while. I need to go to my.
So the other problem that I've got, guys, is this. This is quite a big problem. Does this also account for that, Barney? My lateral star trails looking south.
Ow. I don't know. We'll have to model it and try. I just need to find it first.
Wouldn't it be really scary if we all came up with ideas and we put them all together and it actually worked?
Actually worked. That would be very scary.
Yes.
No, it would be awesome. I love that.
That would scare the shit out of me.
So how do they do it when they have, or someone has tried to model it before? Do they have multiple suns then?
No, what Barney was just on about is this personal dome. But with the personal dome, you can pretty much augment anything outside of that, whereby it's only an intersection.
Right, because it's
so,
just right. The dome is basically interfacing everything to make it look like whatever it is outside.
The problem, it is.
Yeah.
The problem with that is that's no universal explanation for anything. That only explains it personally. Anybody else, you're screwed.
Yeah.
That was like Arwin's. Did you hear me talking to Arwin when he said the sun is an optical phenomenon, like a rainbow? Brilliant.
Yeah,
so how can we get energy from it and all that kind of stuff? You know.
So why couldn't they? So going with Arwen's idea, right? Just thinking through it. Why could there not be a whole dome with just these artifacts showing up, almost like a large screen? I know we've still got to get sun from somewhere, haven't we? We've still got to get energy from.
Well, yeah. So the problem is you can independently and not optically verify the direction of that energy. Doesn't matter that.
You know, it's not just a visual effect.
Yeah.
I see what you mean. It's a real effect, isn't it? Okay. All right. Yeah. Okay.
We can do this. Hashtag we can do this.
I'm sorry, you're in.
Well, it's not like they're going to do it.
Possibly not.
All right, are we thinking the wrong way? Right, we've taken the globe and we've flattened it out. Okay, so surely to get a model that works, we should take the sky, which is a globe as well, and flatten that out. I'm just trying to think, like, doing the reverse because it's a reverse shape. So, yeah, no, I need to think about that a bit.
Wouldn't it be bad if we ended up with concave Earth that actually worked?
Have you tried that just to see what it?
No, and I'm not gonna. I don't think, because that would be that'd be too scary.
Concave is probably more likely to work in more places than flat.
That's what I mean. I think it'd work more than flat, wouldn't it? Concave, because you'd get some level of inverse curvature, wouldn't you? So some of your light effects would probably work okay.
But there's lots of stuff that still wouldn't. Radar wouldn't work. In fact, radar would be completely and utterly screwed on.
How does the moon work here, Dean? How does your moon come up and go down? How do you get your moon phases?
Well, at the moment, you don't, and this would have to get in. I've got to alter the orbit paths to make it so that I do get the different phases. But the other problem that I've got with this is without that fractured light, first of all, taking it down to the surface, I've got a problem. The other problem that I've got is, so there's two explanations for this. It's its own light source, which obviously is you can kind of look at the detail on it and realise that it isn't, because you get shadow, and you can kind of verify that the sun is actually lighting it really easy. So I'm not interested in it being a light source. So now I've just got to deal with the phases, and the problem with the phases, there's a bigger problem in the fact that if I'm below in, where are we? Wait a minute. If I'm below in Tanzania at the moment, looking up, I see a part of the sun which I'd never see ordinarily, and that's this ass end. You don't see that ever.
Of the sun or the moon?
Sorry, the moon, because it's because it's tidal lock. Yeah, sorry, I kept saying sun, didn't I?
Yeah, the sun.
I meant
but don't you have another problem that because the sun is now so close, isn't it? Because yours is a local sun, right? How are you going to get your moon shadows then?
3,500 miles. With great difficulty. But
just the distance. I'm just trying to work out whether the distance changes the. Is that real? That's ray tracing at the moment, isn't it? Right. So
not ray
real.
tracing, but garage shading, which will actually, if I rotate this round, we do get a different phase. Wait a minute, Jesus, something went wrong there. There we go. If I rotate it round, we do get a different phase of the sun here, of the moon. I don't know why. I've got a hard on for the sun.
I keep saying exactly the sun. But you do get different phasing, don't you, from your observation point there? That's working okay. You're getting.
Yeah. Problem is when I'm here, my my cubic energy kind of starts to screw things up a little bit.
Yeah, it does. It's very close, isn't it?
Yeah.
Yeah. The exposure on the moon is going to be a hell of a lot different.
It is, exactly. And how do you get a full moon? Okay, full moon is there, isn't it? Looking from someone to the left.
Well, no, the full moon is opposite in this, but yes, you'd also get a full.
That's what I mean. Someone looking from there, would get a full moon, wouldn't they? Yeah. Not an easy thing, celestial mechanics.
It's mysterious.
Could just say that God does it.
You need to be a god, exactly. That's an easy answer, isn't it?
But I don't get, I've asked flat earthers to give me help on trying to work out how all of these problems, how we can fix just one of these problems. I'm not even interested in.
Well, what happens when you show it to them, Dean, right? Because this is pretty. I mean, I'm really struggling, right? And I'm thinking there's a load of other problems that we haven't even started thinking about, right? And I'm seeing problems already. Because it's really nice to have a model to look at.
I'm sorry, have you tried a sphere with a moon 238,000 miles away and the sun miles away?
Yeah, do you want to see it? It also works out and can predict the orientation of the crescent on the moon in Argentina. So go figure that one out. Which is quite different to central United States at the same time.
Sight unseen, I think that sounds like a plausible shape.
I know. When you measure the altitude of aircraft with when you compare the altitude and range of aircraft with radar, there's some real problems, because when your radar is looking up at half a degree, instead of being able to see an aircraft at 300 kilometers and 2,800 meters, it has to be at in excess of 10,000 meters.
I've still got atmospheric lensing to put in, but I'm going to build that into my fractured light as well. So that's another interesting thing. What that navigator was just saying is that the dome, for his stuff to be even close to being accurate, the dome would actually have to be half a sphere.
That's right, exactly.
Perfect
half a sphere.
over this, yeah. And it gets less accurate the further south you get as well.
Well, the point was all of his celestial objects were at the same height, right? All the stars.
Well,
moon,
but then you've got a problem getting down to the tip of South America.
Found it. Because the original video is gone, but I found a mirror by somebody.
Oh, nice.
By Globebusters.
Cheers for that, Barney.
Is Slick still on? You still there, Slick? No, maybe he's dropped off. I just wondered what his views were on this, because he's obviously been listening away.
I don't think he'd have a view on this.
No, it's beyond. Okay. No, it's just interesting because I'm struggling with it, trying to see it. I'm trying to look at some other, the classic problems. Yeah, it's difficult, right? It's real.
With what this thing you're showing here?
Yeah, I mean, so I'm trying to look at it from the point of view now of a flat earther to solve the problem, right? I'm a problem solver, right? So I'm looking at it as Dean asked, to try and see if we can get it to work, right? I'm struggling, genuinely.
Well, I could see the struggle, because it's kind of like making a reality and then trying to discover the reality in it.
Let's try to match a model to reality.
Right, but that there, see, you're trying to take something made up and see what's real about it.
What the flat Earth's made out. So normally, Slick. So what I do, my job quite often is modeling things, right? And I have limited information sometimes, and then we sort of backward engineer things, right? Where we take it and we sort of model different bits of information about. I admit that Earth is a very complicated thing, but you know, we try and model things to solve the problems, right? You know, and then do it in reality quite often. And I'm, you know, I think this is a valid way to approach it. It just points up a lot of difficulties, and I just wondered whether you saw any of them, what your opinion might be on it. That's all.
Yeah, when it comes to this stuff, like I said, I don't really have any opinion on it because it just doesn't mean anything. Somebody draws something up, you know, and they go with it and say this is it. That's just, I don't subscribe to that at all.
Right. So in your head, you don't imagine what the Earth actually looks like.
Well, it's one of those things with me is that the Earth is just what it is. I mean, it's, you know, it's easier for me not to try to form some belief in my mind that I don't need when I could just accept reality for whatever it is.
Okay, that's a fair comment. So you absorb your reality as you walk around in chunks that you see of the world around you and streets and houses. I get all that. I can accept that. But what drew you then into the whole Nathan debate show then? What was your particular reason for coming into the debates then?
Well, let me just back up a little bit. Why did I come into flat Earth? Period might be a better question.
Okay.
See,
Yeah.
Okay. So what happened with me was I ran into the thing on, you know, like everybody else ran across the information. And when I got into it, long story short, after about 7, 8, 9 months, it was driving me nuts because I kept hearing different, basically good evidences for both sides. So I decided to walk away from it because I couldn't stand it. And I couldn't, when I walked away from it, I couldn't stand it even more because now I was left in this like ambiguous state. So I got back in trying to find something that I can hold on to, anything, just to, you know, put my foot into something. And then finally one day I was sitting down and I said to myself, you know what? I'm just going to clear my head of everything, you know, just so I can, you know, and I'm going to start from that position. So I cleared my head of all thought, all preconceived ideas, anything I've ever been taught. And I said, now, based on that, what do I have? And so I look around and I say, well, what I have is a flat, motionless experience. So now that's not saying that I believe the Earth is flat, but if I clear my mind of anything anybody taught me, that's what I'm left with. So that's why I said, well, now here's my starting point. I know for a fact that I at least experienced that. And so I'm not going on any hearsay. I will only accept anything that's a fact from there on. I'm not going to go with anything that may or may not be wrong or right.
Okay, so don't you then struggle? And I understand that point of view, Slick, by the way. And I'm not an opponent of yours, right? I like that way of thinking. I understand it. It's logical, at least. I don't. It's not what I do, but I understand the logic of your experience there. Of you take it as you find it, and you look at it, and then you build on that. I get that. That's a coherent way to think. Don't you struggle then when you hear people like QE? I think mainly. Sorry. Oh, carry on. Someone like QE talking about the whole, you know, gets very excited about this whole, you know, space, second law, thermodynamic stuff, which to me seems very, very abstract from the experience of the Earth as we find it and the information that we can deduce from first-hand experience.
Right. And then I probably left a little bit out because when I started going on that show, that was in my early stages of my understanding. And after I got in there for a while, I found out that stuff that QE's talking is crazy.
Okay, yeah, because I think it is. I mean, it genuinely is just as bad as whatever other things, that people say. It's right. Okay, all right. I understand your view. Thanks for explaining that.
Oh, yeah, sure. Because like I said, it was like going from, see, what they were doing was like, I went from just letting, going from beef, what I'm saying? Now they're trying to defend them. See, I'm not doing that because I'm open to whatever reality. I don't have a problem hearing evidence, it doesn't.
So then you saw through the thing that was just as bad that's trying to put another model and another set of beliefs in place. So have you found anything that you can grab onto from the point that, as you say, where you've got, like most people, very confused between the two different things and then you cleared your mind? Sure. Have you found any, because that's Mark Sargent's things, but have you found anything you can hold on to that you can say?
there's a lot of things that point, like I'll give you an example, like the model. The model works just fine, okay? I mean, you can see that, everything fits the tilt, the orbits, the eclipses with the 5-degree moon off the ecliptic, and that's how you get your solars and your lunars. But it still just leaves a lot of questions. I ask a lot of questions, and there are some that just don't add up that I can roll with,
And what are the ones, the big ones for you then that don't add up?
Well, most of the things that don't add up for me is the things that happened before that. See, this is the thing. Our world is described to us. Now, the same people that describe our world to us are also telling me that they know exactly how the universe began, what happened every step of the way after that, how stars form, how planets form, how everything. You understand? So when I hear people say that, at some point, they're not sure of that. There's something that you can't be sure about, but they're talking about it like they are. See, so that bothers me, that somebody would stand on something that they're not sure of. So I don't know where the line is drawn between reality and fiction when it comes to that.
But a lot of people do get convinced by their research and come to a definite conclusion for themselves and find it upon themselves to convince others, right? Individual scientists can have their mind made up about, like, let's say David Deutsch, and is definitely convinced that the multiverse exists, where multiverse is pure speculation that cannot be proven, right? So far. But he has researched it so much that for him, there is no other explanation that holds water anymore. Everything has so many flaws, and this is the only thing that keeps things together in a way which works. Now, we are very well aware that there is such disconcert in scientific understanding. When we talk about quantum physics and stuff like that, a lot of people don't agree what the right interpretation is or whether there is any interpretation possible.
Right.
That happens. That's okay. That's fine. But denying things which are obvious and which are literally apparent to everybody and demonstrable, that's the part where I find flat earth lacking.
I guess the problem with that is, Barney, that different people have different elements of what's obvious to them. Do you see what I mean?
Of course. No, absolutely.
So, and then you get people, and I think it's good to question things, but I think there is a little bit of a tendency amongst, let's call it that type of contrarian community, to question then everything as well. And for me, that's a little bit naive, right? To question everything, right? I think it's good to question things. I had a lot of questions, which is why I kind of entered this and obviously looked into it myself. But I think to just then say, right, so all vaccines are bad, nuclear power doesn't exist, the earth is flat, anything government tells us is wrong, whatever, there are aliens, there is Bigfoot, you could go on and on about
Yeah? Absolutely. There is a big difference between questioning everything, which I support to its farthest extent, and concluding that everything is wrong.
Yeah, agreed.
Right?
Yeah.
So
I think questioning everything is fine, but I think concluding everything is wrong is not fine.
Slick, that thing you said today about, well, all I'm asking for is the possibility that if in the conversation of not being certain, of not being sure. But yeah, we don't say things like that because our epistemic limits are also evident and assumed to us. We don't know everything.
Right, but see, here's my problem. Then they should say that. See, this is the
they do.
Well, they don't. Listen, everything is taught like they know what they're talking about. Whenever I listen to programs, whether it's BBC, any official mainstream cosmology program, is never talking about we assume. They say, well, this is what happened. This is what's going on. See, so they're not dividing that line. And when they do that, I can't take them seriously because as far as I'm concerned, you could be making it up. Now, if they were honest, if they were a little bit more honest, then I might be more apt to take them seriously.
So I very, very much agree with you on popularization of science, though I've come to terms with it and have learned to, like, journalism and documentaries about science and low-level education, such as elementary school, science, popularization of science, those things tend to try to transfer an idea, especially the unintuitive ideas, by stating them as fact and stating them as an analogy and then retelling the same analogy over and over again without the people who are making the program understanding it themselves, right? And when you go into scientific literature, when you talk to the people who do this research, understanding and worldview is true and factual, they will still guard themselves against saying that it's the absolute truth.
Right. But see, here's my thing. Like, the problem that I have is this. We have people walking around thinking they know something because they saw it in a book. I mean, this is what has happened to mentality. All of a sudden, you can read something and it just seems official. And because of that, they're willing to stake their life on it, not realizing that they're just believing it. See, so that's my point. You know, you'll have somebody with a theory, right? And the way they sound, they got their lab coat on, they got the PhD from all of these different places. And they'll go on a podium and do a lecture and sound so convincing. Then you'll turn right around and hear somebody else with another PhD with a totally opposite view. When I listen to quantum mechanics, okay, that's information. I don't sit up there and try to buy into it and say, oh, wow, this is this. Because I can't test that. I don't have a photon gun that I can go buy at Home Depot and see if it shoots full. You have that kind of power, you can mislead a lot of people.
But at the same time, my question.
Well, people did this and these people do that. No, I know I got a phone in my hand just because of that. That doesn't mean that now all of a sudden I'm going to start believing what people say because I got a